So vectors is due this week. It's a repeat of the arrays assignment in my view, although there is a problem in there that uses classes. And then we have this application development, and this is the big area, application development. Yeah, question?
On classes, I just had a question. Did we have to split it up how you wanted it before, or how you were showing us?
Yeah, do you need to split them up?
Like in 3 different things? Do we need
Well, in exercise 1 you don't, okay? What about exercise 2? No, I didn't ask for it.
Okay, I was just making sure.
Yeah. Some quarters I asked for that, but this year I didn't ask for that. Anything else? Any other questions you want me to talk about classes or vectors before I jump into application development? Yeah.
I just have one question on why we have to do a certain thing.
Yeah.
Let's just say for the example 1, for the rectangle one.
The vectors? No, example 1?
Yeah. Just
down here, right?
On classes, yeah.
Oh, classes?
Yeah, it's just as classes.
Classes. Example 1 down here? The number class?
No, I mean for the homework. It's just a concept question.
Oh, here, the rectangle, okay.
Yeah. Why did we have to call, like for me, I only was able to get the function to work if I called rectangle to rectangle using the double semicolons? Yeah.
Oh, you couldn't just do rectangle without any arguments, right?
Yeah.
So as soon as it defines some constructor, the compiler will no longer generate automatically a no argument constructor. So if you define no constructor, the compiler will generate for you automatically without you seeing it a constructor that takes no arguments and does nothing. It's just there. But as soon as you define some constructor, for instance, in the rectangle class, we define a constructor that takes 2 arguments. As soon as you define some constructor, the compiler will no longer automatically generate a no argument constructor. So that's why you would, if you wanted a no argument constructor, you would need to implement one yourself.
So that's how we call rectangle to rectangle, basically.
What's that?
This reminds me where I have to call rectangle to rectangle on my code for it to run. So that's why basically it's not no longer an variable.
But I still not quite understand. You want me to look at it?
Yeah.
All right, gotta sign in. That one, right?
Yeah.
Got it. So classes. Here we go. So here's your no argument, your constructor, 2 argument constructor. And there's the implementation. So it looks okay. So, I mean, it looks all right to me.
What confuses, so the only thing that I need help clarification on is lines 47 to 50 on why we have to do that. For my code work, I had that.
You need to have this, right?
Yeah.
Yeah, that's the constructor. You have to tell it, you're giving the definition of this. See, here you implemented these in line. If you had done this, let me show you. I'll comment that out. Now, we'll see it fails to compile. What the heck? You are in, I see, you're up in there, right? All right. And, okay. Undefined reference to, you see it?
Yeah.
That's a constructor. So it's undefined. So we declared it here, but we didn't define it. So we can define it. All you got to do is that. That's good enough. Of course, it's not a good definition, but you know it'll compile now. What is going on? Oh, I forgot this. You see that? So these are, area is defined here, is square is defined here. So you don't need external definitions of them. Let me show you that. So let's suppose that we wanted to take the definition of area out here. All right, then this is now an externally defined function. Whoops, all right. This is, what am I gonna do? Alt-tab, no, Shift-tab, there we go, Shift-tab. And this is a rectangle. It's in the rectangle class. See, I pulled the function out, then I had to put that prefix in there to tell the compiler that this is a function definition in the rectangle class. And now we can take this out. See, now we'll take this definition out here. See that? Watch this. Just delete that. Now it's just a declaration. It's not a definition anymore. We put the definition of the function out here. Now it compiles. So those are two styles. This is, you know, I guess they call this an inline. I think they may call it an inline definition. Here's inline. And here's a regular definition out here. So this would be more typical, I believe, to see it outside the class declaration block. See, this is where we declare the structure of the class, right there. So let me take the is square out now. Actually, what am I doing? I'm going to undo. Command Z. There we go. Let me let you do it. Why don't you take out the is square function, just the way I took out the area function. We'll watch you do that. Are you in there?
Yeah. Oh, I'm typing. I'm doing the.
Oh, you're down there. I thought you were going to copy and paste. You know, that would be a little faster, right? Yeah. Okay.
Accidentally take off the.
There we go. Also, this constructor up here, we need to set the width and X. We need to add to the body. Can you fix that? This constructor body, I put nothing in there, but really we should set width and height to the two arguments coming in.
So we can set width equal to X.
Yeah. Very good. So you remember to do that. See, Now we need, you can declare a function without giving names to the arguments. Just provide the data type. But as soon as you use the arguments, you got to give them a name. So that's what you just did. You put it in the names X and Y. So this is good. Let's see if this compiles. That's good. See if it runs. Of course, maybe to be consistent, we would do this. I'll just do this. To be consistent, oh, what am I doing? What am I doing? I gotta take that off so it's this, okay. To be consistent, we would do something like this. I'll just tighten it up there. See, now all of our functions are declared in this class declaration block, and all the definitions are external. You could take the X and Y out up there, but I always leave them in. But that's up to you. You can remove X and Y up there if you like.
Oh, it doesn't matter.
Doesn't matter. It's just style. You see, no code is referring to X and Y here.
So I ran into this, I wasn't here for the classes lecture, but I was finding that like, it made more sense to me like if I'm declaring a rectangle constructor to have the two parameters you pass, like instead of saying double X, double Y, to just have them be double width and double height. But that doesn't work, right? They have to be named differently. Because I would like, it wouldn't work when I said like width equals width, height equals height.
Dustin, you know how to fix that? Let's suppose we said this was width. Well, not here, but it's like down here. Suppose we called this width here. And we called this height. Oh, by the way, this is not spelled right? It's Heighth, right? How can you fix that?
If you have reference to E on every single one.
Okay, see now this X is now called width.
So
Remember, you have to use this.
Yeah.
So how are you going to do that? This width. So that's the width, that's the member variable width. This is this height, that's the member variable height. And now X is no longer X, it's now width, right? Y is no longer Y, it's now height. Can you fix those? So you can't use X here. You want the first, that X is simply the first argument to the function. We change the name of the first argument. No. We want the argument to be called width.
So where do we want to change? So since we have starting with X, do we have to change the top one also? So we have double width?
No, these don't matter. These don't matter. I will though. I'll put it in there. These don't matter. Just for documentation, I'll set it. But this has to. X is no longer defined. What is that X supposed to refer to?
Double width.
It's the argument, the first argument that's passed into the constructor. But we changed the name of the first argument, so we're going to change X. X is we just changed X from X to width.
We just change it back to width.
Yeah. See that? See this width, this name width here refers to the name of the first argument. This height here refers to the second argument. But this width, actually it's this width, does not refer to that. It's a different width. It's the David on the 3rd floor. Which width does this refer to? It refers to the member variable width here. Right? So that's yeah, it's very common to see the code. I would say this is the most common style, to have redundant names. So they have to be differentiated using some kind of prefix. And to give them different names, that would be it's also, you see that out there in people's code, but it's less common than this. It's hard to annotate it, isn't it? Actually, this is a pointer to the object instance. I'll give you an example here. You've got these objects right there. And see how we call, is square there? Well, we could do the following. We could take a rectangle pointer. And we'll make it we'll use the address of operator. So PTR is declared, that has to be an asterisk. PTR is of type pointer to rectangle. So we want a pointer to say foo. So this is an address of operator. It's not the reference variable. It's not the reference parameter symbol. I mean, it's the same symbol, ampersand, but it's used in this context. It means something different. This ampersand right here says, whatever follows it, give me the address of its location in RAM. Give me the byte location of this foo instance, this foo object. And once you give me the address of foo, store it in the variable PTR. So PTR is not a rectangle. It's not of type rectangle. It's of type pointer to rectangle. See? This is how you say pointer to rectangle, like that. You have the asterisk following the name of the class. So now, with PTR defined like that, we can call the isSquare function using the pointer. But you got to use this arrow, see? So PTR is a pointer to the foo instance. And this is how you call its isSquare function. So up here, in this constructor, you're inside a function in the class. So this has a special meaning. It's a pointer to the object that you're running against. Like here, these are all, see there's this width here, that width here is not the width up here. This width is only, this width that I've highlighted right there is only visible in lines 40 and 41. It's a function parameter. It's only visible inside the function. But so this width up here cannot refer to some other function parameter. That's in a different area, different scope. This width is the member variable width, the width that's defined here. So we could say, now this isSquare is being called against an object. See, we don't just call isSquare by itself. We don't just say assert, isSquare is false. We can't do that. It's meaningless. We have to tell it which object to invoke isSquare on. Now, when the isSquare function runs, it's running in relation to some specific object. the foo object, not the bar object, the foo object right now. And so when we can use this pointer here, see, because this is defined, this is just it's the pointer to the object that the function is running relative to.
So what's the benefit of using a pointer to an object that you've already named the object?
Not much of a benefit. Well, in this case, there's no benefit. This just adds confusion to the program. But there are other situations in which you want to use a pointer. I'll give you one example. There's this thing called virtual functions. And if you can have a pointer to a base class, and when you, and maybe so it has to do with inheritance. And I'll just tell you, because we didn't study this, so I'll just say it really briefly. Absorb whatever you like from it. You might have a base class like shape, and subclasses. You may have a subclass called rectangle, another subclass called circle, and they're all extending the parent class called base. Now maybe you create an instance of a rectangle, and you have and you want to store it in a vector of shapes. So you've got 5 rectangle instances, 20 circle instances, 3 trapezoid instances, but you just want to put all of those references to those instances inside of a vector of shapes. So you declare the vector of shape pointer. You could declare, it'd have to be declared shape pointer. And then you put into the vector pointers to all those shapes. And now you want to call the is_square function, right? Or it's called the area function. That's more believable that you would call the area function against all the shapes in the shape vector. I don't care if it's a circle. I don't care if it's a rectangle. I just want to know the area. Okay, you got 20 shapes in that vector. I want to know the total area. So I'm ignoring the differences that one's a circle, one's a trapezoid. So I iterate through the vector and I call the area function against each one. Now the calculation of area for a circle is different than the calculation of area for a rectangle. But those differences, I just want to ignore those. I'm just calling the area function. And then if the object happens to be a rectangle, it's going to be width times height. And if the object happens to be a circle, it's going to be pi times r squared. But those differences I don't need to see, when I iterate to that vector of shape. So for that scenario to work, you have to use pointers. There's no other way to do it. You'll learn about that if you take 202 or study C++ on your own. You'll read about inheritance and virtual functions. And then there's other areas where you need pointers. Like maybe you have a rectangle instance, and it's needed. References to that instance are needed in 10 places throughout the program. Of course, you could pass around references. You could always do it with references, but a lot of programmers use pointers instead. But in C++, if you want to do that virtual inheritance I was talking about, you have to use pointers. You can't use references. Anyway, I don't want to keep talking about that. It's just probably too advanced. We need to look at inheritance and think more about that to really understand the reason for this. So I'll just take that out for you. And that's that. There we go. And you see this a lot. And I wanted to show that today in this, this topic here called application development. And in this assignment, there's this unit conversion problem to do, computing change. I'll let you work on those by yourself. I've got hints in there. This is an important hint. Make sure you read that. And this one you have to work out. So these are challenging problems. They're not too hard. You can do those. Then I've got some extra credit problems. And here is here's an extra credit problem. You know, to implement the game tic-tac-toe. And here's another one, which is on graphics programming. So I wanted to talk about this today. But you know what? I need to take